Yes. Yep, whatever email you have on file is the one that will get sent to. Unless you have a different one, then if you let me know, I can send it to that one. Okay, so an introduction to limits. Okay, so what if you have a sketch of f of x equals x to the third minus 1 over x minus 1, and we know that x can't equal 1, because if x is equal to 1, you have a denominator of 0. Okay, so with limits, we know that x can't equal 1. So what we want to know is, if you get really close to 1, what's the highest or the lowest number that you'll get? So what we're going to do is we're going to get really close to 1. Okay. So let's say if we're approaching 1 from the left, we'll make it 0.75, say 0.9, get a little bit closer to 1, 0.99, let's say 0.999, and we know at 1 can't be anything because it wouldn't exist, because we have a denominator of 0. Okay, so let's say if we want to approach 1 now from the right, so we'll start with 1.25, 1.1, 1.01, and 1.001. Okay, so x approaching 1 from the left, and we have x approaching 1 from the right. Okay, so we want to know what number will we have when we get closer and closer and closer and closer to that number that we can't equal. Okay, so if you put in 0.75 into that equation, you'll end up with 2.313. If you put 0.9 in there, you'll end up with 2.710. Okay, if you put in 0.99, you'll end up with 2.97 or 970, and it keeps on going. Okay, if you end up with 0.999, you'll get 2.997. Okay, so you can kind of see where it's leading towards. Okay, now if we approach it from the right, if you put in 1.25, you'll end up with 3.813. If you put in 1.1, you'll end up with 3.310. Okay, if you put in 1.01, you end up with 3.050. Sorry about that. 030, I was right. Okay, if you put in 1.001, you end up with 3.003. Uh-oh. Go ahead and erase that. 3.003. Okay, so as you get closer to 1 to the left and closer to 1 to the right, it's getting closer and closer to 3. It'll never reach 3, but it's getting closer and closer to 3. So if we were to look at this graph, let me slide that up a little bit. It would look something like this. And let's say, look. That's your x-axis, that's your y-axis. This graph is f of x equals x to the third minus 1 over x minus 1. This is your 1. And that means as it gets closer and closer to 1, your f of x value gets closer and closer to 3. It'll never, like I said, never actually gets to that value, but it gets really close to it. So once we find out the number that it gets really close to, we know the limit of f of x equals x to the third minus 1 over x minus 1 as x approaches 1 is 3. Okay. Now you don't have to write all of that down. There's actually a shortcut to it. We'll make sure. Okay. That's just the limit of x to the third minus 1 over x minus 1 as x approaches 1 is equal to 3. Okay. So that's just a shortcut way to say that entire sentence. Okay. Any questions on that one? All right, so let's do one more. Okay, so let's say, for example, bring that down a little bit. There we go. Oh, just a quick heads up. I think this only has like a 30-minute record window for some reason. So when that disappears or stops recording, let me know so I can just push the button and start it back up. Okay, so we have to estimate the limit of the function f of x equals x over square root of x plus 1 minus 1 as x approaches 0. Okay. Or in other words, the limit of x over square root of x plus 1 minus 1 as x approaches 0. Okay. So it's a lot easier just to write that instead of that entire blown out sentence. Okay, so to start that, first thing we do is we create our little graph there. So you have x, you have your f of x. Okay, so we want to get closer and closer and closer to 0 because we plugged in 0. We have 0 plus 1, so I have square root of 1, which is just 1. 1 minus 1 is 0, so it will be undefined. So we get as close to 0 as possible. Okay, so we'll have, sometimes it helps just draw out a number line. So if you want to 0, you can just say negative 0.01, then negative 0.001, then negative 0.0001. So it's getting closer and closer and closer to 0. Negative 0.001. Negative 0.0001. Okay, so we know when we eventually hit 0, it's undefined, so it's nothing there. Okay, so if we have 0.0001, oh, 0.0001, sorry about that, 0.001, and 0.01. Okay, so we're going to get closer and closer to 0 from both sides. So if we plugged in negative 0.01, we'd end up with 1.99499. If we plugged in negative 0.001, we would have 1.99950. If we plugged in negative 0.0001, we'd have 1.99995, and it keeps going and going and going. So you can kind of see from that direction where it's headed. Okay, now if we come in from the right, if we plugged in 0.0001, let me clean that up a little bit. Okay, we'll get 2.00005. If we plugged in 0.001, we get 2.0005. We actually should have started at the other end, but you kind of see where I'm going. If we plug in 0.01, it's 2.00499. So should have went that way, but as you get closer and closer and closer, you see it's getting closer and closer and closer to 2. Okay, so we can actually estimate the limit is 2. Okay, so if we drew that out in an actual graph, it would look like, let me see. You have your x-axis and your y-axis. That would be an open circle, and it would keep on going, somewhat like that. Okay, so that would be 1 there. So as it gets closer and closer to 0, it'll never have an yes.
Okay, so you see on both sides of the function, you going from the positive and then from the negative. As they come together, you see that the numbers are similar in their difference from 2. Will that always be the case? That they will be parallel with each other?
Oh, no, not always.
Oh, so okay.
Sometimes you'll have them come from one direction and the other, and they won't match up at all.
Right. So,
Yeah.
So my second question would be is, how do you figure out the limit then?
Oh, there are a bunch of different ways. We're going to kind of go step by step to that one, but yeah, we will eventually get to that one. All right, so let's say we know that, that would actually be, we know that value is 2. So the limit of x over square root of x plus 1 minus 1 is x approaches 0 is 2. Okay, any questions on that one? Yes.
Are you just calculating this like all in your head, like?
Oh, no, I did this ahead of time.
Oh, okay, I was gonna say like.
Oh no, not that good.
Okay.
Nope, did these all ahead of time. All right. Now we have a list of properties that we have for limits. Same way you have like properties for exponents and stuff like that. We have the same properties for limits. Not the same properties, but they also have properties. Okay. Now we have what we call direct substitution. Well, in the 2 previous examples, we knew that we couldn't plug in that number. It would never equal 1, it would never equal 0, because it would give us the denominator of 0. But whenever you have a limit to where the denominator won't equal 0 at that point, you can just plug it right on in. Okay, so if you have, let's say, okay, so we know we can find the limit of a function as x approaches c. Okay. This is where we can now find out what if the limit of that function f of x as x approaches c is just f of c. So that means if you're approaching 1, what if it's the same as it would be if 1 were not undefined? You could actually just do that. Okay, so we can find that by direct substitution. Direct substitution. Okay, which is really just a fancy way of saying when you get that C value, just plug it right in. That's really all it is. Okay, so let's say if we have our basic limits. Okay, these are just kind of the everyday, limit behaviors that you want to look at or remember. You don't really have to memorize them. Once you use them, you'll kind of know what to do with them. Okay, so the first is that the limit, well, we'll say, let C equals any constant. So it's just, C just represent any number, that's all. Instead of putting in a 3 or a 4, we just let C be anything. So the limit of any number, oh, actually make that B because I already have C. There you go, I'll let that be B. I forgot I already had as x approaches C, so that wouldn't make any sense. Is equal to that constant. Because remember, all we're going to do with direct substitution is replace that C with any x variable. If there are no x variables, then there's nothing to replace. Plus, you can also think about it, if you have y equals 5, it's just a straight line. So what's the limit of that straight line? Is just going to be 5. It's not going to go up. And as you're approaching it from the left or right, it's always going to be 5, no matter what you're approaching. So when you have that single straight line, the limit of that is just that straight line. Does that make sense? All right. Okay. Oh, do a quick example here. So the limit of 15 as x approaches 38 would still be 15. Whatever that constant is here, that's going to be your limit. Okay, it could be x approaches 12, it will still be 15. As x approaches 0, it's still going to be 15. Okay. The limit of x as x approaches c, remember, all you're going to do is plug in that c and replace that x value. So if you plug in that x with c, the limit of x as x approaches c is just c, whatever that constant is. So for example, let me kind of separate that a little bit. The limit of x as x approaches 4 would just be 4. Or the limit of 2 as x approaches 0, oh, limit of x as x approaches, sorry about that, thinking of the one before. Limit of x as x approaches 0 is just 0. You're just going to plug that c value right into the x. Okay, any questions on either one of those? Yes?
Both of them, you're basically doing it like as it goes on the graph, it would just be like just flat y equals 5 or whatever you said?
Yep, so all it is, if you picture the graph of x or y equals x, it's just a slanted line going, it's just a slanted line going up like that, where you have your x and your y-axis like that. Okay. So as you're approaching 0 from the left or the right, it's just going to equal 0. So as the limit approaches 0, that's what it's going to equal. Does that make sense?
Kind of. That's for the limit of x equals 0 as x approaches 0. Okay.
Yeah. So even if you made it x equal the limit of x as x approaches 5. If this is 5, then the limit as you're approaching from the left and the right is just going to be 5. Because remember, y is equal to x, so 5 is going to equal 5.
So what about the example that we did above as in like let b be the any constant for when x approaches say 38 or?
Oh, yep. With that one above it, if you look here, now we'll use this one. We have the graph here. You have your x and your y. Let's say y is equal to 5. Okay, so the limit of 5 as x approaches 1.
Oh, okay.
Yeah, so as you get one on either side, it's going to be 5. If x is approaching negative 27, as you approach it from the left and right, it's still going to be 5.
Right.
Yep.
Okay.
That make sense?
Yeah.
Okay. No problem. Okay, so the third, the limit of, say, x to the power of n as x approaches c. Once again, we're just going to replace the x with c. It's going to be c to the power of n. Okay. So all that's saying is that if we plug it in, that limit is actually existing at that point. So that's why we can just plug in the c, because it exists. Before, we couldn't just plug it in because it wouldn't exist, it would be undefined. But whenever you can plug it in and it's not undefined, that means it goes right through that point. It doesn't have to stop and start on the other side of it. It goes right through it. Does that make sense? All right. Okay, so quick example. Have the limit of, let's say, x cubed as x approaches 4. Just plug in the 4 into the x. That would just be 4 cubed, which would be 64. All right. Okay, so we're going to do a few examples of direct substitution. Okay, let's say if we want to find the limit of, let's say, 3x squared minus 4x plus 8 as x approaches negative 1. Okay. So we know here that if you plug in negative 1, it won't make it undefined. So that's how you know you can just plug it in. Now, if this was over x plus 1, you couldn't plug it in. But because plugging in a negative 1 won't hurt anything, just plug it in and you can go to the next one. Okay. Now, you could just plug it in and solve it from there, but we're going to kind of do the steps a little bit so you can see how the other properties work. Okay. Now, if you wanted to with a limit, you can kind of distribute it using the distributive property. So you can just distribute it to each one of those terms, which means you would have the limit of 3x squared as x approaches negative 1 minus the limit of 4x as x approaches negative 1 plus the limit of 8 as x approaches negative 1. Okay, so you can distribute the limit. Okay, you can also factor out a constant if you wanted to. So this one, you can just factor the 3 out to the front. 3 times the limit of x squared as x approaches negative 1 minus 4 times the limit of x as x approaches negative 1, limit of x. Here you just have the limit of a constant. It's just going to be that constant, so you don't have to factor anything out. Okay. And now that you have all of them pretty much simplified to just a function of x, just plug them in. So that's 3. As x approaches negative 1, that's just going to be negative 1 squared. So times negative 1 squared minus 4 times the limit of x as x approaches negative 1 is just negative 1. You plug that right on in. Plus the limit of a constant as it approaches anything is just going to be that constant. So that's just going to be 8. And then we just solve from there. So negative 1 squared is 1. 3 times 1 is 3. Plus 4 is 7. Nope, hold on. Yep, -1, 4, plus 8. I don't know where I got 7 from. -3, hold on. Oh, this should have been cubed, never mind. I messed up on my original equation. So instead of squared, that should have been cubed. Sorry about that. I knew it didn't look right. There we go. All right. So now that should be -3 plus 4 plus 8, which is equal to 9. All right. So any questions on that one?
So how you distributed it, you just took those first properties that you learned
Mm-hmm.
and then just applied them to each one.
Yep.
So whatever number's in there, you bring it out to the front to multiply it.
Yep, that constant in front of, once you distribute it, you can just bring the constant right on out. Mm-hmm.
Is it gonna say do direct substitution, or is there something we need to look for to know?
Whenever, the first thing you want to do whenever solving for a limit is to plug it in. And if you plug it in and nothing is undefined, then you're good. So if you, the only way this wouldn't work is if it was maybe over x plus 1. Where if you plug in,
This question on like a test, the first thing you'd want us to do is.
yep, first thing you do is plug it in, see if it works. All right, any other questions? All right.
So,
Mhm.
sorry.
Mhm.
So when you mean, but, wait, now if you just put -1 is in for x, that wouldn't solve the problem.
Oh, it would.
Okay,
Yep,
it's
you
just, this
just-
is another way to.
Yeah, if you just went right to here and put in -1 and there, and there,
Yeah.
yeah, it would be big deal. This is just a long way to show you the properties, that was all. But yeah, if you plugged it right in from the beginning, probably 20 seconds later you would have been done, so.
I just was curious.
So
Yep.
will we be getting deducted points if we go by that route, or?
Oh, no, not at all. No.
Are we allowed to use calculators on our tests?
You can, but you would still have to show
Show
the steps. So if you were to do this, if you tried to plug with the calculator, just gave me the answer, you wouldn't get full credit. But if you show me this step and you replaced all of those with a -1, yeah, then you get step. Then you're showing me, okay, you know exactly what to do, not just plug it in. Yes.
So do we necessarily need scantrons on the test? Because you're saying if it's like, because I know it's multiple choice, it's set on the facility.
Yeah, you will have some multiple choice questions and some will be
okay.
fill in. So it'll be
So
kind of,
it's gonna be
yeah, both. Yeah.
Okay.
Right. But even on the multiple choice ones, if you just guess the right answer without showing any of the work, it wouldn't be marked right. It would still be wrong. You would have to show the
Right,
steps.
makes sense.
Yep. All right. So let's do one more. Okay, so let's say, for example, we have the limit of x cubed plus 2x squared minus 1 over 5 minus 3x as x approaches -2.
Is this another direct substitution?
Yep, because if you plug in -2, as long as you don't have a 0 in the denominator, you're good. Yep, so you can just plug that one right on in. But, of course, I'm going to take the long route to kind of show you the different properties. But if you wanted to go ahead and plug it right in, you're more than welcome. Okay. Now, when you have a fraction, you can just distribute the limit to both of them. So you can do that too. So this would be the limit as x approaches, oh, make sure I'm up front of, yep, -2 of x cubed plus 2x squared minus 1 over the limit as x approaches -2 of 5 minus 3x. That's just another property that I wanted to point out. You don't have to do it that way, but in some cases it may come in handy.